A beautiful warm day. Every kid in the world must be outside enjoying the sunshine, right? Well, maybe not. While it might be warm and sunny where you are, the weather can be very different at other places in the world.
It could be pouring rain,
or freezing cold and snowy,
or scorching hot. But why do different places have such different weather?
Sounds like a question for our kid weather watchers around the world. Learning about the weather is just like learning about anything else. You have to investigate. Are you ready? Okay then, let's go. We all know that the weather can change from day to day, or even from hour to hour. And of course, the weather changes throughout the year. The average weather pattern of any one place is called its climate. Two important parts of climate are temperature, how hot or cold it gets, and precipitation, how much rain, snow, or ice falls. Scientists who study the weather are called meteorologists. Meteorologists measure temperature and precipitation over many years so they can see what patterns there are. They also measure things like how windy it is, how cloudy, and lots more.
But what makes the weather different from place to place?
Well, there's no one single answer to that. There are lots of things that make weather different in different places, but there is one big reason, something that has a lot to do with weather no matter where you are in the world. The sun. The most important thing we need to know about the weather is that it pretty much always has to do with the sun.
That makes sense. I mean, it's either sunny or it's not.
True, but it's much more than that. The sun is the main source of heat and the driving force behind weather.
So weather depends on how much sunlight a place gets?
Yes. Take a look at the Earth, spinning like a top in space. It goes around once every 24 hours, one full day. When your side of the Earth is facing the sun, it's daytime. When it's facing away from the sun, it's nighttime.
I get it. That's why it's usually warmer during the day than at night. Because during the day, you're facing the sun.
Right. When sunlight hits the Earth, it makes the surface of the Earth warmer, and that makes the air warmer too. But there's something important you have to remember about sunlight. Sunlight is energy. When sunlight hits an object, some of that energy heats up the object. The more directly or straight on it hits something, the more that thing heats up. Here's a way to see how this works. You'll need a square piece of cardboard, 2 markers, one red and one blue, a meter stick, some tape, a flashlight, and a friend. First, lay the flashlight over the edge of a table and tape it down so it won't move. Next, tape the cardboard flat to the middle of the meter stick. Now lay the stick between 2 chairs in front of the flashlight so the light hits the board right in the middle and the circle of light is not too big. Think of the flashlight as the sun and the cardboard as the Earth. Stand the board so it's straight up and down. While one person holds the stick steady, the other person traces the circle of light on the board using the red marker. Now keep the stick right where it is, but tilt it over so the board is at an angle. Make sure the light is still hitting the center of the cardboard. Hold the stick steady and again trace the shape of the light on the board, this time using the blue marker. Now you can turn off the flashlight and take a close look at the shapes you traced. The smaller circle shows where the light was hitting the board when it was shining directly at it. What's different about the other shape on the board? This is where the light hit the board when it was not shining directly. As you can see, the second shape you drew is much larger than the first, even though both were made using the same light. If this were sunlight heating the Earth, the red area would heat up more than the blue, because the sunlight is more direct. So that means the places on the Earth that get the most direct sunlight are the warmest.
All right, I get it. But why does the amount of direct sunlight change?
Because the Earth is round. Sunlight only hits straight on, right in the middle. The rest of the Earth is still getting warmed by sunlight, but not as much, since it's not hitting so straight on. Because the top and bottom of the Earth, the North and South poles, don't get as much heat from sunlight, they stay very cold. But the part of the Earth halfway between the North and South poles, called the equator, gets the most direct sunlight, so it's the hottest part of the Earth overall.
So the general rule is that the closer a place is to the equator, the warmer its climate. And the farther a place is from the equator, the colder its climate.
Hang on, weather watchers, because you're about to enter the climate zone. Remember, there are all kinds of climates on Earth. Hot and dry, cold and snowy, warm and rainy, and everything in between. But to make it a little easier to understand, meteorologists have them grouped into 3 basic zones. That's right, climate zones. Okay, weather watchers, let's have them.
We'll start at the top. The bottom. The top and the bottom. The polar zones are at both the North and South poles.
Polar climate is very cold because, as we've seen, the very top and bottom of the Earth get no direct sunlight at all. So there's not much warming up going on there. In fact, it's generally freezing. Okay, the next zone.
If it's warming up you want, then the place to be is the tropical zone. It's easy to find. Just follow the equator all the way around the world.
Remember, the equator is the part of the Earth that's generally the hottest. In the tropical zone, the climate is usually hot and can be rainy. One more zone to go.
I guess I'm stuck in the middle, in the temperate zone, in between the polar zones and the tropical zone.
Places in temperate zones can be cold and snowy in the winter and can get pretty hot during the summer. This wide range of temperatures and conditions is no surprise. It's part of the climate. Just because we know a place is in a particular climate zone, it doesn't mean that we can be sure of the weather there. Lots of different things can affect the weather. And you can check it out just by looking in your own backyard.
Hey, it's warmer in the sun than in the shade.
Of course. Places that get more sunlight usually have a warmer climate than those that don't.
I noticed that it's usually hotter on the concrete than it is on the grass, even when they're both in the sun.
Right again. Some things, like concrete, heat up better than others. That's one reason why cities are usually warmer than the country. What else?
On some cold mornings, there's a frost on the grass, but near the house there isn't any.
That's because the heat from the house keeps the dew on the grass from freezing. That's kind of like what happens in places near the ocean during the winter. The warm air over the ocean can keep those places warm enough so they get rain instead of snow. There are other things besides how far a place is from the equator that influence its climate. But let's not just talk about it. It's time for a field trip. First, pack your gear. You're off to the beach. Then you're headed to the mountains. And finally, you'll be going inland, away from any oceans. Okay, here's our first report, just in from the beach.
As I traveled closer to the ocean, I noticed a change in the weather. I expected it to be all sunny, but there were also a lot of clouds, and then it rained. The people who live here tell me it's like that a lot.
Great report. Being close to water, like the ocean, is one of the things that can greatly affect climate. For one thing, it's not surprising that it rained. After all, rain is water. So it makes sense that places near a body of water tend to get more rain than places far from water. Places near the ocean tend to have warmer winters and cooler summers than places far from the water. That's because water heats up and cools down much slower than land does. So in the summer, The cool water keeps the air cooler too. And in the winter, it's the opposite. The warmer water keeps the air from getting so cold. Here's an easy way to see for yourself how water changes temperature slower than land does. Take 2 identical bowls and fill one with plain old water, the other with dirt and rocks. Let them sit out on the counter for a couple of hours so they're both at room temperature. Now place them both next to each other in the sunlight. Use a thermometer to take the temperature of both the water and the dirt every 15 minutes over the course of a few hours. Be sure to write down the temperatures and observe any changes over time. What you'll find is that the dirt and rocks in the bowl got warm much faster than the water did. It's the same idea with land and oceans. Land heats up faster in the summer and cools off faster in the winter than oceans do. And that affects the temperature of the air above. Because the air above the land and water are often at different temperatures, it can often be rather breezy at the beach. During the heat of a spring or summer day, cooler winds tend to blow from the ocean toward the land. That's called a sea breeze. At night, it's the opposite. That's called a land breeze. Okay, next report in from the mountains.
Well, it was quite a climb, but we finally made it, and boy was it wild. It was raining, but warm at the bottom of the mountain, but as we got to the top, it got cloudier, windier, and much colder. Before I knew it, we were coming down the other side. There it got warmer and sunny. What a change.
Ah, what brave souls. The weather in the mountains can change from moment to moment. That's part of the climate. In general, the higher up you go, the colder it gets. So places up high usually have colder climates than places down lower.
But why was the weather different on each side of the mountain?
Well, as winds blow up one side, the air cools down, and that creates clouds.
And when you have clouds, you usually get rain or snow.
Exactly. But on the other side of the mountain, it can be a completely different story. Air blows down that side. As it does, it warms up and dries out. That means fewer clouds.
And fewer clouds means less rain.
One more report from the field. And what a field it is. Check this out.
My journey took me inland, away from any oceans or mountains. What I found left me feeling kind of flat. Actually, that is what I found. Flat ground and lots of it. And lots of blue sky, too.
This giant area of flat land is called a plain. Remember those dry winds that blow down the side of a mountain? Well, they often keep blowing right across the plains. This gives plains a climate with lots of sun and wind, but not much rain. And being far from large bodies of water can also mean some pretty extreme temperatures on plains found in the temperate zone. Really hot in the summer and really cold in the winter. Let's review what we've learned about climate so far.
Climate is the average weather of a place over a long period of time.
Check.
Climate is described in many different ways, like temperature, how hot and cold it gets, precipitation, how much it rains or snows in a year, how cloudy it gets, how many days are foggy, and how windy it can be.
Check.
There are different climates all over the world, and the main reason is the sun. The closer a place is to the equator, the warmer its climate, because that's where the Earth gets the most direct sunlight. The farther from the equator, the colder the climate.
Check.
So we understand what climate is.
But we still have one big question.
Why does the weather change so much throughout the year?
Right, I mean, how can one place be cold and snowy for part of the year, and then be hot and sunny for another part of the year?
Whoa, good questions. But the first thing to know is that you're talking about the seasons. Spring, summer, autumn, and winter. Each season lasts about 3 months, and the weather during each season is usually the same every year. That means that if winter is cold and snowy where you live, the climate is probably about the same there every winter. Just like if it's hot and rainy in the summer, it's usually that way there every summer.
But why do we have seasons at all?
Could it be the sun?
Very good. Just as the sun is a big part of climates, it also has a lot to do with the seasons. Remember that the equator is an imaginary line around the Earth, halfway between the North and South poles. But there's also another imaginary line called the Earth's axis. That goes right through the Earth from pole to pole. It's this line that the Earth spins around. But if you look closely at a globe, you'll notice that the Earth's axis is tilted, and that makes a big difference.
How does the Earth being tilted make the seasons? The Earth is always spinning, right? And it's always tipped to one side as it spins. It seems like nothing is really changing.
Very observant. But there's still one important point we haven't talked about. As it spins, the Earth also travels around the sun, going around once in a year. Together, it's these two things that cause our seasons on the Earth: the tilt of the Earth and the movement of the Earth around the sun. But I know someone who can explain it even better. Meet Dr. John Neese. He's the chief meteorologist at the Franklin Institute Science Museum in Philadelphia, Pennsylvania. And today, Dr. Neese is going to give us the inside scoop by demonstrating a device called an orrery.
Well, an orrery is a device that has the sun and other members of the solar system. Some orreries only have the sun and the Earth. And it's those orreries that we can use to explain why the Earth has seasons. Well, it really takes two factors. First of all, the Earth revolves around the sun. Once a year, the Earth makes a complete orbit around the sun. If that didn't happen, we wouldn't get seasons. But that's not enough. It's the tilt of the Earth. Have you ever noticed that in a globe, the Earth never seems to stand straight up and down? That the globe makers tilted the Earth, and you ever wonder why that is? Well, the reason, when you put the Earth in space next to the sun, the Earth's axis actually is tilted relative to the sun, and that's what causes the seasons. So now let's put those two pieces together and make seasons. You have the Earth tilted on its axis and the Earth revolving around the sun. Now what that means is, at some times of the year, the northern half of the Earth, the part that's north of the equator, we call it the northern hemisphere, will be more directly facing the sun. And more direct sunlight means higher temperatures, and that's summer. At the same time, the southern hemisphere isn't directly facing the sun. It's sort of facing away from the sun. The sunlight is less intense, lower temperatures, winter. But 6 months later, the whole picture reverses. Now the southern hemisphere is more directly facing the sun. More direct sunlight, higher temperatures, summertime, southern hemisphere. But in the northern hemisphere now, facing more away from the sun. The sunlight is less direct, lower temperatures, wintertime.
In between summer and winter, the Earth is still moving around the sun. So halfway between summer and winter, we have autumn.
I call that season fall. And halfway between winter and summer, we have spring.
Spring, summer, autumn, winter. You've got it. Just like climates, seasons are not the same all over the world. Folks in Brazil may not even need to wear a light jacket during winter. But in a colder climate, kids might be bundled up and playing in the snow. On the other hand, summer in some desert regions brings long days and an average high temperature of 105 degrees Fahrenheit, or 40 degrees Celsius. While in the cold reaches of Siberia, average summer temperatures barely reach 60 degrees Fahrenheit, or 15 degrees Celsius. As the Earth moves around the sun throughout the year, the seasons are constantly changing. That also means different things in different climate zones. Temperate zones have the most change throughout the year, with days that have more hours of daylight in the summer and days with less daylight in the winter. Places in the tropical zone get about 12 hours of sunlight every day all year round. And some places in polar zones have sunlight all day for about half the year. Then they have darkness all day for the other half of the year. Okay, so what have we learned about seasons? What causes them?
For one thing, the Earth is tilted on its axis.
And the Earth revolves around the sun.
Those two things together cause some parts of the Earth to get more direct sunlight for a longer time each day,
That's when we have summer.
and some parts of the Earth to get less direct sunlight for a shorter time each day.
That's when we have winter.
The seasons are a cycle, which means they repeat over and over again, never stopping.
It sounds like weather is always changing.
It is. But remember, by observing the weather over long periods of time, meteorologists can see different climates in different parts of the world. And the seasons are a pattern that repeats again and again. Understanding climates and seasons helps us know more about the weather where we live and all around the world.